These are the frequently asked questions for Algebra 2 for Section 8.4, Day 2. I'll start with number 25. And 25 says divide. And what we want to do is always pay attention to what's going on with the denominator at any stage of the game. So right off the bat, we can see here that one of the restrictions we're going to have for the variable is going to be 0. Y cannot equal to 0. Now, we need to get started by saying, okay, in factored form, what does this look like for number 25? So, I take a look at y squared minus 5y plus 6. There is no common monomial factor. It's not a perfect square trinomial. So I'm looking for two numbers that multiply to 6 and add to negative 5. And that would be negative 2 and negative 3 over y cubed. And then we have y squared plus 3y minus 10, and with that one again, you'll see that there's no common monomial factor, there's no special pattern to it, so we are looking for two numbers that multiply to negative 10 and add to 3. So multiplying to negative 10, you start thinking through what you have, and hopefully before long you get to your 5 and 2 and you realize it'll be plus 5 and a negative 2. That would give you that 3 in the middle. Now, again, the reason we're writing it out this way is to see, and we can start our restrictions now, that y cannot be 0. But now we know this is division, and we do not divide fractions, we multiply by the reciprocal. So keep your first fraction exactly as it is, your first ratio, but then what we have to do is we do have to take the reciprocal of what we are dividing by, which means we're going to flip the second fraction here. And when we do that, we realize we have a couple new restrictions right here, and that's going to be y cannot be negative 5 and y cannot be 2, because that would have us dividing by 0. And now let's go ahead and do our canceling, the fun part. We have a y minus 2 here and a y minus 2 here that will cancel out, and then we can take a couple of these y's out of here. But that's it. So now let's collect it all back together. In the numerator, we still have a 4, and we still have a y minus 3. In our denominator, we have a y, and we have a y plus 5. And checking one more time, we see that now still obvious that we cannot use 0 in the denominator or negative 5. So these are a lot of fun. Once you get that factoring piece going throughout this, and you start seeing things cancel, there's a lot of manipulation that you can do with these. Number 29 has some great stuff here. This is, again, simplify each rational expression and state any restrictions on the variables. So I'm going to start by doing some factoring, and you'll notice when you look at the numerator that they have an x and a y in both terms. So that's a common monomial factor, and we need to pull that out. And then you think, okay, what would be left if I was to pull that out? And with our denominator, we can see that there's a 12 and an x in all of those terms. So again, you think about, well, what would I be left with if I pulled that out? Or you think, okay, what would I work backwards to get? So 12x times y squared would give you 12xy squared. 12x times y will give you 12xy. 12x times negative 12 will be negative 144x. Now, we don't have this broken down entirely because after factoring the first time, we notice we can factor again. Y squared minus 9, that's a difference of 2 squares. So that's y plus 3 and y minus 3. And in the denominator, we have y squared plus y minus 12. It's not a perfect square trinomial, but it's possible that we can factor that. So we start thinking of two numbers that would multiply to negative 12 and add to 1, and that will be plus 4 and minus 3. So right now would be a good time to stop and write down those restrictions on the variable, because we can see our denominator and we can see that we can't use 0 because that would have us dividing by 0. We can't use negative 4 and we can't use 3. And I better quit writing x's there because they used y's in this problem. There we go. And last but not least, let's do the fun stuff. Let's do the canceling. So the x's that are out in front will be gone. Again, there's pure multiplication there, and that's the only case that we can use canceling for because canceling is division. The y minus 3's will cancel out, and then we just need to keep track of what's left. So in the numerator, we will have y times the quantity y plus 3. And in our denominator, we have a 12 and the quantity y plus 4. And then one last check just to make sure that there's nothing else that we could cancel, that we didn't lose along the way, and that we picked up everything that hasn't been canceled as we go through there. So this is our answer. And these are its restrictions for number 29. So a lot going on in those problems. Keep track of all of your factors and things should go just fine. Number 34, look at these. Multiply or divide, state any restrictions on the variables. So first thing we want to do is go through these in factor and see what we have. And I'm going to start with my numerator for the first fraction. There is no common monomial factor, and 2 is not a perfect square. So we are simply looking for two numbers that multiply to -2 and add to -1, and that's going to be -2 plus 1. Now, the bottom of this fraction has that combo issue. You know, we have to have a combination of numbers. And there's no common monomial factor. That's how we know this is going to happen. We absolutely know that it's going to be a 2x and an x that are going to give us 2x squared. But now we have to do a little thinking because we need two numbers that multiply to +2 but add to a -5. And that's going to be -2 and -1. But the placement of those numbers is important because we have to end up with a -5 in the middle. So as I do outside times outside, I see that it would be a good idea to have a -4 and then a -1 for inside times inside to get that -5. And then that's going to be divided by no common monomial factor for x squared minus x minus 12. 12 is not a perfect square. So two numbers that multiply to -12 and add to -1 would be -4 and +3. And then in the denominator of this one, we have a similar situation where we're thinking, okay, there's no common denominator, or common monomial factor we can pull out of this. So that's going to be a 2x and an x in the front. And this time, we've got a little more trying to do because the numbers have to multiply to -3 and somehow outside times outside and inside times inside have to add to 5. Well, a really good way to do that would, with this combination of numbers, be a 6 and a -1. So if I put +6, so +3 outside times outside will be +6, and -1 in the middle, that will give me 6 minus 1, which is 5. Now here's where I want to start my list of restrictions. From the first fraction, 2 would be a bad number, and so would 1/2. From the second fraction, there's that 1/2 again that would be bad, because if 2x minus 1 equals 0, we would add 1 to both sides and divide by 2, and then -3 for the second fraction. Now, this is division. We don't divide fractions, we multiply by the reciprocal. So I'm going to rewrite the first fraction exactly as it was. But now I need to take the reciprocal of the second fraction so that I can start doing my canceling. All right, let's see what we have. We have a 2x minus 1 that will cancel with a 2x minus 1. We have an x plus 3 that will cancel with an x plus 3. And we have an x minus 2 that will cancel with an x minus 2. So we're pulling together what's left, and our numerator is x plus 1, and our denominator is x minus 4. And one of our new restrictions when we flipped this was that we now had an x minus 4 in the denominator, which means that we need to come over here and add 4 as a restriction, or you could wait until the end and add that one there too. But always good as you go through the steps to say, okay, do I have any new restrictions that I need to add? Because my denominator has changed. So factoring checking for restrictions, then flipping, checking for restrictions, and finally doing your canceling. I'm going to go after number 35 now. Number 35. I will do this one the way that we taught you how to factor any of those trinomials that have an a value that is not 1. And I see 2x squared plus 5x plus 2 and realize there's not a common monomial factor. So what I need to do is come up with all the combinations of numbers that would multiply to 2 in the front, and then all the combinations of numbers in the back that would multiply to 2 but somehow add to a positive 5, and that is just going to be 1 and 2 again. And then what we need to do is check all the combinations with outside times outside plus inside times inside until we manage to get a 5. So outside times outside, 1 times 2 would be 2. Inside times inside, 2 times 1 would be 2, and that would only give me 4. So that's not going to work. I go down to the next combination. 2 times 2 is 4, and 1 times 1 is 1, and 4 plus 1 is 5. And then I have to remember that this came from first position and first position and last position and last position. So this will be 2x, 1x, plus 1, plus 2. My denominator, 4x squared minus 1. I cannot pull out a common monomial factor, but I notice it's a difference of 2 squares. That's 2x minus 1 and 2x plus 1. And then we have another binomial that does not have a common monomial factor, and it has a number that is not 1 for the a value in standard form. So in the front, the numbers that would multiply to give me 2 are 1 and 2 and 1. And in the back, it has to multiply to a negative 1 and add to 1 somehow using outside times outside plus inside times inside. So the only numbers that are going to do that are negative 1 and 1. And then again, you try your combinations until you get positive 1. The first set here, 1 times 1 would be 1. 2 times negative 1 would be negative 2. 1 plus negative 2 is negative 1. That does not work. Then we use the second set. 2 times 1 is 2. 1 times negative 1 is negative 1. And 2 plus negative 1 is 1. So that's the combination that we need. And this is first, first, last, and last. So this will be 2x, x minus 1 plus 1. Then our denominator, x squared plus x minus 2, there is no common monomial factor. Negative 2 is not a perfect square. So we need two numbers that multiply to negative 2 and add to 1, and that's going to be positive 2 and minus 1, negative 1. Now let me clear this because I want to make some room to write down my restrictions at this point. Restrictions to the domain, any of those numbers that if we put them in our denominator would have us dividing by 0. So these two would give us x cannot be 1/2 and x cannot be negative 1/2. These two would give us x cannot equal negative 2 and x cannot equal 1. Again, because if it did, then we would be dividing by 0. Now, I don't have to do any flipping with this one because this one was multiplication. So I get to just go straight to canceling. 2x plus 1 with 2x plus 1. 2x minus 1 with 2x minus 1. X plus 2 with x plus 2. And we are left with simply x plus 1 over x minus 1. And then all of our restrictions right over here. And again, the check at the end shows that we still would not be able to use 1 at this point. Number 36 says, write a simplified expression for the area of the rectangle at the right. Show all restrictions on A. And we know that the area of a rectangle is length times width. So we need 3a plus 9 over 2a minus 6 times 4a plus 4 over a plus 3. So we can start with restrictions right off the bat here. Once we get it in our factored form, because this is definitely not factored. So we have a 3 as a common monomial factor for our numerator, so that will be 3 times a plus 3. We have a 2 for a common monomial factor in our denominator, and that'll leave us with a minus 3. And then on the numerator of the second fraction, a 4 will come out of that and leave us with a plus 1. And then we have a little a plus 3. So our restrictions are a cannot be 3, because that would make this a 0, and a cannot be negative 3. Now, let's get canceling. Because this was multiplication, we don't have to do any flipping or anything. The a plus 3's are gone. The 2 will factor out of the 4 and leave us with a 2. And then we do numerator times numerator, 3 times the quantity a plus 1 over the quantity a minus 3. And we already have covered our restriction of a not being 3, so there are no new restrictions. Number 42, wow, this is a cool problem here. Simplify, state any restrictions on the variables. So you're thinking, what on earth am I supposed to do with that numerator? Well, if you're thinking that, then you probably better write it out twice and see what you have. Because remember, that power means we need that twice. Now, we have an x down here, and we have this nasty x minus 1 to the negative 2 power. But I'm going to go ahead and factor x squared plus 3x minus 4. That is no common monomial factor there. Not going to be a perfect square or anything, because it's a negative 4 in the back. It has to be a positive number in the back to be a perfect square. So I'm going to put my x's in and think of two numbers that multiply to negative 4 and add to 3. And that's plus 4 and minus 1. So this is my first stop for restrictions. And x cannot equal 0 because of that x right there. X cannot equal 1 because of that one. X cannot equal negative 4. And again, x cannot equal 1. So we have another x minus 1 there. Now, I hope it's been bugging you that there is a negative exponent in this thing. We have a couple of things we have to take care of. First off, hopefully you saw that now that we've pulled these apart, there's an x that needs to come out of both of these. So that means we can write this a little bit differently. We can put x times x, which is x squared, and then we would have x minus 1 squared. And that would be what this would look like in factored form. Now I also need to bring this x minus 1 to negative 2 up to the numerator. So it will become a positive 2. And now that's taken care of, and we have x times x plus 4 times x minus 1. And now that we have two sets of parentheses in our numerator that are exactly the same, that means that is our base, and we should be adding these exponents. So that will now be a 4. And we have x and x plus 4 and x minus 1. All right, so what's next? Well, let's stop and make sure we haven't added any new restrictions. This would be 0, this would be negative 4, and this would be 1. 0, negative 4, and 1. So those are taken care of. So next step would be to cancel. And we see that we have some x's here, one that could leave from the top and the bottom. And we could take one of the x minus 1's from that numerator and cancel it out in the denominator. So what we're left with is x times the quantity x minus 1 to the third power. And our denominator would be x plus 4. So no new restrictions added in those last couple of steps on 42. But still kind of a fun problem. There's a lot going on there. All right, then, number 44. Decided to do this one not because I think the math is difficult, but I want to make sure that everybody's checking those restrictions right away before we do any movement here. So x will not be able to be 0 and y will not be 0 because of the fact that they are both in the denominator to start with. Now, different things to do at this point. We have 54x to the third y to the negative 1 over 3x to the negative second y. You could go ahead and do the division of the 54 and 3 right away. That would not hurt. That's going to come out to 18. And then I would probably just use subtraction, because when we are dividing similar bases, we subtract. So 3 minus a negative 2 will be 3 plus 2, which will be x to the fifth. And then negative 1 minus 1 would be negative 2. And then we can go ahead and put that term that has the negative power in the denominator, and that's going to give us a y squared in the denominator. And one last check here, and we said that y could not equal 0 already in our restrictions, so we don't need to add any new restrictions to that one. 48 and 49. Now, they are just telling us here that this is just a different look to something we've already done. They're saying we're going to take 9m plus 6n over m squared n squared, and we're going to divide that by 12m plus 8n over 5m squared. Again, you're just writing in a different way. And these are going to be called complex fractions. We have a fraction within a fraction here. So here's what we need to do. We need to talk about restrictions right away so that we can avoid any numbers that would make us divide by 0. And that's going to be when m or n are 0. So we have to take those out. Now, next thing we would want to do, factor all of this and see what we have. So 9m plus 6n, we could take a 3 out of that, and that will leave us with 3m plus 2n. M squared and n squared is just going to have to hang in there for a little bit. And 12m plus 8, we could take a 4 out of that and get 3m plus 2n, which should look familiar, over 5m squared. Quick check for restrictions at this stage still shows us that m and n cannot be 0. Now, we're going to leave this first fraction exactly as it is, but we need to change division to multiplying by the reciprocal. So this is going to be another step where we stop and find our new restrictions. And those new restrictions will come from this, right back here. And what we're going to have to say is that 3m plus 2n cannot equal 0. Then, let's see what we can cancel. The 3m plus 2n will be gone. The m squared will be gone. And we are left with 3 times 5, which is 15, over, and then we have a 4 and an n squared. So, now, what to do about that last restriction in number 48? Well, we tend to not leave it in this format. Here's why. Because we have both an m and an n in this, what we'd want to do is just pick one of those to describe the other one by. What I mean by that is we're going to go ahead and solve this for one of the variables. And the first variable they used was m, so we're just going to go ahead and solve for m. So we would subtract 2n from both sides. So 3m equals negative 2n, and then we would divide by 3. So our new restriction to cover this problem is going to be that m cannot equal negative 2/3 of whatever n is. That will cover that last case. And the reason, again, that I went after m was because that was the first variable that they identified in this problem. So generally, that's what we try to stick with as a rule. Let's see. I do have one more up here, one of those complex fractions left to do. All right, so let's rewrite 49 the way that we're used to, which would be x squared minus 1 over x squared minus 9. and then we're dividing by x squared plus 3x minus 4 over x squared plus 8x plus 15. Now we need to look at the restrictions, so we're going to have to go ahead and factor. And our numerator here, pretty obviously, we've seen this difference of two squares several times, so x plus 1 and x minus 1. And the same thing with our denominator, that's going to be x plus 3 and x minus 3. And then I check out my numerator from the second fraction. There's no common monomial factor. It's not a perfect square because that's not a plus 4 in the back. I need two numbers that multiply to -4 and add to 3, and that will be plus 4 and minus 1. My denominator, there is no common monomial factor, and 15 is not a perfect square, so that's not a perfect square trinomial. Two numbers that multiply to 15 and add to 8, pretty obviously 5 and 3. So it's time to write some restrictions. First one, 3 and -3. Second one, -5 and -3. So we just need to add the -5 to our list of restrictions. Now we have to change that division to multiplication. So x plus 1 times x minus 1 over x plus 3 times x minus 3 times x plus 5 times x plus 3 over x plus 4 times x minus 1. All right, new restrictions. Well, we still have our -3 and 3 over here, but now we're adding -4 and 1 to that list. And then, let's cancel. So let's see what we have here. We have an x plus 3 that will be gone. We have an x minus 1 that will be gone. But that's it with this one. So our numerator will be the quantity x plus 1 times the quantity x plus 5 divided by the quantity x minus 3 times the quantity x plus 4. And we take a look and realize there are no new restrictions at this point, that we have them all covered. So let's see, I believe, yep, that is it for this assignment.